All right, so this problem comes from 5.2, and it asks to divide these rational expressions. But in order to divide the rational expressions, we have to be very comfortable with factoring. So let's pull this to the side for a minute, and let's look at some factoring problems. So I put this factoring problem up here, and it's in this ax squared plus bx plus c format. And if your a is equal to 1, it becomes an easier problem to factor. And when I mean factor, it means that I'm going to take a trinomial and put it into two binomials that when multiplied will equal this. So this coefficient on the x squared is our a, the coefficient on our x is our b, and the coefficient or the constant by itself is c. So in this case, I want factors of 21 that sum to negative 10. So my factors of 21 look like this. And only one of them sums to negative 10, and it's this last one. When you add the two numbers together, you get negative 10. So I'm going to say x minus 3, x minus 7. This is the two binomials that when I multiply them and use my FOIL method, I'm going to end up back to this trinomial. Now, the factoring becomes a little more difficult when you have an a that's not equal to 1. So let's look at a problem where a is not equal to 1. So let's try this one. So the method that I talked about in class was that we would do this slide and divide method. So let's erase this. And so the slide and divide method says I take the a and I slide it down. So I take the 2 and I'm going to slide it down to the c. And so I'm going to write x squared plus x minus 12. And so now now that my a is 1, I want factors of c that sum to b. And the factors of negative 12 are negative 3 and 4, or you could do 3 and negative 4. These will add up to 1, but this one adds up to positive 1 and this one negative 1. So I want to choose this one. And now it's slide and divide. So I have to divide out what I slid down, which was 2. And so I can't simplify this 3/2 any further, so I'm going to slide the 2 back in front of the x, and this becomes x plus 2. So the factored form of this would be 2x minus 3 times x plus 2. So I've now, if I wanted to check this, I could FOIL it, and I would see that I end up back to this place. And where it gets more complicated yet is when you have two different variables. So how can I work through a problem like this? So what you can do first is similar to the method we're talking about, kind of multiply that leading coefficient by the coefficient of the last term. And so if I multiply those two together, I get 2 times negative 15 or negative 30. And what I want to do is find two numbers whose product, so when I multiply it, product means multiply, is negative 30, and the sum is 7, just like we did before. So product 30, sum is 7. So let's write out those factors of 30. Now, I know that one of them has to be negative. So 30 is divisible by 2. It's also divisible by 3. It's also divisible, it's not divisible by 4, but it is divisible by 6 and 5. So when I add them together, these two numbers multiply to give me negative 30, but add to give me 7. And so I'm going to replace this original middle term with minus 3xy plus 10xy. And then I'm going to do the factoring by grouping that we talked about. And we're going to see if I write it like this, can I factor out a greatest common factor? Well, they both have a common factor of 2 that we factor out. Of x, I'm sorry, x. I think I said 2. And I'd be left with 2x minus 3y. And here they both have a common factor of 5. 10 and 15 have a common factor of 5. And then also a y. So I'd end up with 2x minus 3y. And now I completed the factoring by grouping because these pieces match. So I'm going to write x plus 5y and then 2x minus 3y. And so now I factored this one. So don't let the multiple variables intimidate you. Try with, when you end up with these, try the factoring by grouping and see if that will help you solve these. So let's move back to the problem from this section 5.2. So I have the problem right here, and I'm going to have to factor each of these 4 parts, and then I'm going to have to divide. So I can factor each, I'm going to factor each of these separately. So let's start with this one. This is the first part here. And I'm going to, and this is where I have the 2 variables. So think of it as I have 12, 4 times 3 here. And I want them to sum to 13. So I'm going to factor by grouping. So the factors of 12 that sum to 13, well, they are 1 times 12. And so I'm going to rewrite this as a squared plus, I'll start by writing it like this, a plus 12, I'm sorry, ab plus 12ab plus 3b squared. So I want to write it like that so that I can factor by grouping. And so I'm going to try doing these 2 and these 2. And so between the 2 of these, I can factor out a, and I'll be left with 4a plus b. And between the 2 of these terms, I can factor out a 3b, and I'll be left with 4a plus b. So I do have this piece in common, and so I can rewrite this as 4a plus b times a plus 3b. So that will be this part. So I'll replace the top of it with this factored form. Then I'll move on and I'm going to do the second part. Now that one, 16a squared minus b squared, this is a difference of squares problem. The reason why I know that is because 16 is a perfect square, a squared is a perfect square, and so is b squared. So I'll take the square root of 16a squared. I'll take the square root of b squared. So when I write my binomials, it'll look like this. One has a plus sign, one has a minus. So that's going to go in place there. Now, let's do this third one here. And so that's a squared plus 4ab plus 3b squared. Here my coefficient in the front is 1, so I don't have to think about sliding anything down, but I still want to factor, when I have these 2 variables, and I forgot the b again, I want to factor by grouping. So I want to look for factors of the last term here, coefficient, that sum to 4, and those factors are 1 times 3. So a squared plus, we're going to say ab, so the 1 first, and then plus 3ab plus 3b squared. So all I've done is I separated the middle term into 2 pieces. And so let's now factor by grouping by taking these 2 and these 2. And so here there's a common factor of a, and here there's a common factor of 3b. And now this is in common, so I can write a plus b, and then a plus 3b. So this factored form will now go in place of where I wrote the number 3. And now let's try the last one here. So this one here, I'm going to write it over to the side here. It's 4a squared minus 5ab plus b squared. And again, this is 2 variables, does not have an a equal to 1. So if you were to multiply this by the c, you would want factors of 4 that sum to negative 5. The factors of positive 4 that sum to 5 are negative 4 times negative 1. And so I'll split that middle term, and I'm going to try writing it like this first. And actually, I think I want the 4 in common over here, so I'm going to flip this. Minus 4ab minus ab. And that should have been a minus sign on both of them. And so now, factoring, what's in common here is ab, or 4a. So what am I left with? A minus b. And what's in common here? Now, I put a minus sign here in front of the parentheses, so this will become minus. And I'm going to factor out a b, a negative b, and so I'll be left with a minus b. So the a minus b is in common, and now I'm left with 4a minus b. So that will go in place of the fourth one. So I'm going to replace all of these with the factored form. So let's do that, but I'm going to do it off to the side here. So I've rewritten the problem now in factored form. So now, in order to do division, this first rational expression stays the same. And the second rational expression will flip. So you change this division sign multiplication, and you flip this second one. And then let's see what we can divide out. So we've got 4a plus b, 4a plus b divides out. We've got 3a plus b, a plus 3b here. We've got a plus 3b here. We've got 4a minus b, 4a minus b. So we're looking to divide things out between the numerator and denominator. And what am I left with? A minus b over a plus b. So yes, this is a difficult one. It involves a lot of factoring, and not just factoring of a single variable, but factoring of that double variable, which makes it more complicated. And in order to do those, I think the best way to do them is to use that technique with the factoring by grouping.